Hello everybody, in this video we're going to do part B, or we're going to start part B. Actually we're going to do a side problem. You look at part B, it says from the firm's profits maximization problem, and then we're given the answers. I actually want to look at the derivation process for these values because it could be that we'll have to do that on a test. I think in future midterms, this is 2015, I think in future midterms we'll have to do that. So let's see how to do it. We start with a profit function, which is going to be profit is equal to output. And remember that we are going to normalize the price to 1, so we don't have to worry about prices, which is nice. The firm pays wages times the amount of labor it employs, and it also pays a big R rental on capital. And that's subject to big R is equal to little r plus the depreciation rate. Remember in Ramsey that firms are going to be the ones that think about this depreciation variable, not households. Okay, one other thing we need to do is change this to intensive form, and we're going to do that by saying the production function looks like this, and it's a neoclassical production function. So if we multiply it by 1 over xl, we can just put that and multiply each variable inside by 1 over xl. xl. The xl's go away, and we're just left with f of k hat. And to make it nice for substitution, we're going to bring this 1 over xl on this equation to the other side. So the production function in gross terms is going to be equal to xl times the production function in labor effective capital terms. So let's rewrite this. We're going to maximize with respect to k and l the profit function, which will be xl times f of k hat minus wl minus r plus delta k. And we have two variables, so two first order conditions. Delta pi delta k equals 0, which implies, let's change the color. Here we have a k inside here, so xl come for the ride. We need to use chain rule, so the outside function will become f prime of k hat. And the inside, remember that k hat equals k over xl. So the derivative of that with respect to k will just be 1 over xl. So let's write that over here. And then we have another k, this goes to 0, we have another k here, so minus r plus d, r plus delta equals 0. These cancel, and then we're going to solve for r because that's the rental rate of capital. So r will be equal to f prime of k hat minus delta. And we're done. We have one more first order condition, delta pi over delta l equals 0, which is going to imply that we have an L in both this part and this part, so we need to use the product rule. First we'll just get x f of k hat plus, now xl comes for the ride. We use the chain rule, the outside will be f prime of k hat, and the inside, again, we're going to take delta L k over xl, and that's going to be equal to k over x times minus 1 over L squared, because 1 over L derivative equals minus 1 over L squared. So times minus k over xll. And then there's one more L. Where is it? Right here. So we're also going to have minus w. Minus w equals 0. So we got to clean this up. We have 3 terms. We can move the w to this side, and then we have an x here and an x here, so we can factor out an x. We have an L, and this L cancel, and then what's left here is just k hat. So we're going to end up with x f of k hat minus k hat f prime of k hat equals w. And we almost have what we were given in the question, but we don't have this x in the question. We need to remember that the growth rate of x, which will be x dot over x, is equal to gamma. And we can integrate that from 0 to t, both sides, 0 to t, and we'll ds. Dot derivative over itself is going to be natural log. So we get the natural log of x of s evaluated between 0 and t is equal to gamma t. Gamma is just a constant, so we just get that t. Now here, we're going to define x of 0 equals 1, because there's no reason not to. We can start anywhere, so we choose the easiest place to start. So the natural log of 1 is 0, so this bottom part will go away, and we'll just be left with the natural log x of t is equal to gamma t, and we raise both sides to e, canceling the natural log. So x of t equals e gamma t. So we can substitute that. E gamma t times f of k hat minus k hat f prime k hat equals w. And we're done. And we haven't done anything at all. So in the next clip, I will actually do the problem. See you there.